Hello students, I am Marco Severo. This is the Marketing Analytics course. This is the part 4 of Introductory Correlation, where I am going to discuss a more theoretical concept that is related to correlation, and that is an important feature for marketing managers and for researchers dealing with data in general. Okay. So as we are talking about marketing, imagine yourself that we have a data set from a store in a beach, in a beautiful beach in Brazil, and in this data set we have the sales of ice creams across time. So sales is an important marketing variable, and it's important to have in the data set and to understand the dynamics of this variable, relating it to other variables, okay? And imagine yourself that in the same data set, you have another variable that is the number of shark attacks in that same beach, okay? So in one column of your data set, you have the number of ice cream sales, and in another column of your data set, you have the number of shark attacks. Imagine that you run a regression model for policy analysis where you attribute ice cream sales as your main independent variable and shark attacks as your main dependent variable. So you have as the X variable ice cream sales, and as the Y variable shark attacks. It is most likely that you are going to find a positive relationship if you run a linear regression model. Okay, in that case, your model is telling you that the more you sell ice cream, the more you have shark attacks in a beach. So imagine, for policy purposes, the implications of your model. You are telling to the responsibles for public policies that in order to stop shark attacks, you must stop ice cream sales, because you are finding a positive relationship among these variables. Okay, this is not true at all. And the thing is, you have another process that you have a Z variable, which in this case is heat, that is correlated with ice cream sales, and it is also correlated with shark attacks. So the thing is that you have a Z variable that is related to both and is causing this confusion in your regression model. Basically, the correlation coefficient is a linear relationship among two variables, and the problem is that it doesn't capture theory at all. So if you want to develop a regression model that is appropriated to understand relationship among variables, it must have underlying theory beneath it, okay? And this is a traditional example of a spurious relationship, and this actually does happen in reality. Okay, so there is this famous website which is called Tyler Vision. I think this is the name of the person, and it was a very famous website that it turned out into a book. Okay, I'm going to present two interesting spurious correlations like this one that I just showed about ice cream sales and shark attacks. Okay, so the first one is the number of people who drowned by falling into a pool in the United States, and the number of films Nicolas Cage appeared in. So you can observe that the correlation coefficient is 0.66, so quite acceptable correlation coefficient, and the variables, they correlate across time. So the thing is that the Z variable in this case is time, that is related to both variables, okay? The second variable in this, the second spurious relationship in this case is between divorce rate in Maine, which is correlated with per capita consumption of margarine. The correlation coefficient is almost 1. See here is 0.99. If I run a model, I'm going to find that the more consumption of margarine people undertake, the more divorce rates appear in Maine. So this is not true at all. Okay, so this is the main definition of spurious correlation in spurious relationships, and marketing managers and marketing researchers or data scientists must be aware of it. Okay, so thank you very much.